video, we're going to do some more with rational functions now, throwing some variables in there. So we're going to use your knowledge of fractions and factoring to help with this. Okay, so again, kind of a recap here. How we simplify fractions is we're removing a common factor, and really we're removing a factor of 1, because if you think about it, in this one I can divide both these by 2. Well, if I think about dividing by 2 over 2, 2 over 2 is 1. So I'm not changing what this fraction is worth. I'm just reducing it and keeping it in lowest terms, but it still has the same value. So I can read, 6 divided by 2 is 3, and 8 divided by 2 is 4, so this is considered the fraction in lowest terms. So we're reducing those unnecessary factors of 1 that are overcomplicating the expression. Here we are going to do the same thing. Greatest common factor here is 4, so dividing both by 4, we're going to be left with 1/4. We can do the same thing here. We're looking for factors of 1 that I can take out. So I can reduce 3/6 to 1/2. Now the x's, I can essentially use my exponent rules here, you guys. So I have x to the first and x squared. We subtract when we're dividing. 2 minus 1 is 1, so I'm left with x to the first. It's going to go wherever the bigger one was. So x squared is bigger than x to the first, so it's going to go in the denominator. And you don't have to put the 1 there, you can. We have the same thing with the y's, but y squared is on top, so when I do my subtraction, my answer is going to be on the top. And you don't have to write the 1 in there as well, you guys. This would be the more simplified way to write it. So this x canceled with one of those x's. This y canceled with one of those y's. Is another way to think about that. Okay, let's do this one. 14 divided by 2 is 7. So I'm going to have a 7 on top. Okay, here, again, 2 of those x's are going to cancel with 2 of the 3. So I'm going to be left with 1 there. Okay, so we have x to the first on the bottom. And then I have y squared on the top. Okay. So we're going to be doing a lot of simplifying here to start. So here's kind of what process you want to follow. You want to factor first if you can. Then we're going to cancel common factors, kind of removing again those factors of 1. Now we also are going to state which values make the expression undefined. So for this, values that make the denominator equals 0 are what make the expression undefined. So those values I need to state, okay? So I'm going to show you what that looks like. So here I'm going to factor first. We're going to do the numerator and denominator separately. So on the top, I can factor out a 2. Okay? Now, x plus 6 and x plus 6 are common factors. Those can cancel and we're left with just 2. But we're also going to state which values x could not be for this expression to be undefined. So this is where I set the denominator equal to 0 and I solve. So in this one, x would equal -6. So this is what x cannot be. So we're going to state x cannot equal -6. So this is kind of the other part of that answer. So here's how it simplifies. This is what values x can never be. Otherwise, this whole expression is undefined. Okay, here, same strategy, we're going to factor first. So in the top, I have a greatest common factor of 3x. So then I'm left with x squared minus 2. Oh, sorry, x minus 2, because I took out one of those x's. Okay, and then over, factor on the bottom here, take out 5x. So we're left with x minus 2. So again, I have some common factors. Before I cancel out here though, you guys, I'm actually going to just jump to the part by saying what x cannot be. It's easiest to do once it's factored. So I'm going to set my denominator equal to 0. So I've got 5x times x minus 2 equals 0. This is for me finding what x cannot be. I never want the denominator to equal 0. So remember, this is kind of its own factor. So I can set 5x equal to 0 and solve that equation, and x minus 2 equals 0 and solve that equation. So here, x is 0 and x is 2. These are the two values that x cannot be. Okay, so I'm going to state that right now. X cannot equal 0 or 2. Okay, now I'm going to go ahead and simplify from here. So my x minus 2's, those are common factors, those can cancel. These x's can also cancel, and we are just left with 3 over 5. Okay, this one, same strategy, we're gonna factor the top. This is a trinomial. My a value is 1, so I can just look at numbers that multiply to be negative 21 that add up to be 4, which is gonna be 7 and negative 3. On the bottom, difference of square, well, not quite. I gotta factor out my 2 first, and then I have a squared minus 9. But that is difference of squares, so we can go one step further to say a squared minus 9, I can factor into a plus 3 and a minus 3. Okay, my a minus 3's will cancel, and this is what's left. Okay, so I did this a little early maybe, but I am left with 2 times a plus 3. Okay, so for stating what x cannot be, I want to look at the values before I canceled anything. So that was this phase right here. So I'm going to come back and I'm going to set those pieces equal to 0. So I've got 2, maybe I'm going to do this down below you guys. So here's my simplified, let's do it right here, what x cannot be. So I've got 2 times a plus 3 times a minus 3 equals 0. So this is where I set each group equal to 0. So 2 equals 0, a plus 3 equals 0, a minus 3 equals 0. So this part is really unnecessary, you guys, because 2 can't equal 0, right? So that doesn't provide any sort of value that we're going to need. Just these ones that involve the variables are. So I'm going to get a is negative 3 and a is 3. So those are what a cannot be. A cannot be positive or negative 3. Okay? Okay, last example here. We again have a trinomial, so I'm going to factor this into numbers that multiply to be negative 15 that add up to be negative 2 are negative 5 and positive 3. Okay, here, factor out a 2. Now, something you might notice, you guys, I'm going to show you this 2 ways. These both have the x in front. If I want to cancel anything, they have to look the same. So if I were to rearrange this, okay, I could rewrite this as negative 2x plus 10. And then if I factor out a negative 2, then I'm going to get x minus 5. So the reason for rearranging it is because now this looks the same as this, right? And I'm left with x plus 3 over negative 2. Now, before I canceled, x minus 5 was in my denominator. So set that equals 0. Remember, you don't have to set negative 2 equals 0 because that's not going to solve anything. Negative 2 can't be 0. X equals 5. So x cannot equal 5. Okay, so some common errors, you guys, of things that people try and cancel that you cannot. I want to just really compare it. You can cancel factors, things that are being multiplied. So this x is being multiplied by this set of parentheses, so is this. Because they're both engaged in multiplication, you could cancel those. Okay, here, this and this you can cancel because, again, there's multiplication. This is really x times x, okay, and it's being multiplied by x plus 1. So if I take this x and get rid of that squared, I'm taking that x and taking one of those, what would be left is a 1. So if you take something away and it completely removes the numerator, you're going to replace it with a 1, okay? Okay, things that you can't cancel. These are things that people try to cancel a lot and you cannot because there's no multiplication involved. Here, x and x, I cannot cancel those. This x is not being multiplied by anything. It's being added in this case. So addition and subtraction, I cannot get rid of that term. Same thing here. This x, I cannot cancel with one of those x's. This 6, I cannot reduce with the 12. There's addition in between. I need multiplication if I'm going to be able to cancel common factors. So these cannot cancel anything. Okay. All right, now we're going to do some multiplying and dividing, okay? So multiplying and dividing with fractions, you guys know how to do this already. This is where you can kind of cross simplify or simplify as you go, okay? So right away I can do 4 6, I know I can reduce that to 2/3. Why I might want to do that is because I'm going to deal with smaller numbers this way and I don't have to simplify at the end. So I'm just going to deal with these first two first. So I've got 5 6 times 2/3. This I can also diagonally simplify. 2 goes into 6 3 times. So you can either replace that with a 1 or just keep your 5. Go straight across. So we got 5/9. Now I still have another 2/3. I'm going to check, can I cross? Nope. So I just go straight across. Making sure. Yeah. Okay. 9 times 3 is 27. So if you've cross simplified or reduced as you go, then you will not have to reduce at the end. That is completely reduced. Okay. Okay. So when we multiply with rational expressions, okay, we are going to, again, factor and cancel common factors. Okay, so right now, I'm going to factor this expression. So I've got a GCF of 4x. So I'm taking out the 4x. I'm left with x minus 1. On the bottom, I have a trinomial. So numbers that multiply to be -3 that add up to be add up to be positive 2 are 3 and -1. Times, factor this one. So numbers that multiply to be -6 that add up to be positive 1 are 3 and -2. And then 4x, there's nothing I can simplify there. Okay, so now we can simplify within the same fraction and we can cross simplify. Okay, but before I do that, I'm going to say what x cannot be. So remember, this is setting the denominators equal to 0. So if I set this equal to 0, I would get -3 and 1 that x cannot be. If I set this equal to 0, I would also get 0. So this is part of something that I have to include. Okay, x cannot be those values for this operation to work. Okay, all right, so I'm going to simplify within. So these x minus 1s can cancel. Nothing else can cancel within that fraction. So now I'm going to look across the diagonal. So this x plus 3 can cancel with this x plus 3. This 4x can cancel with this 4x. All that I have left is x minus 2. Okay? All right, division. Remember, our rule of dividing is I keep the first fraction, change to multiplication, and flip the second one. So a lot of people call that keep, change, flip. You might have heard that phrase before. That's what it means. Keep, change to multiplication, flip the second fraction. Okay, so again, you can reduce right now. Like I could reduce this to 3/2. So I've got 5/8 times 3/2. Look at the cross. No other reducing I can have. So multiply straight across. 15/16. So with the dividing part, I'm going to still factor first, and then I'm going to do that process of keep, change, flip. Okay, so I'm going to factor first. So I've got 2x over, factor out a 3 on the bottom here, x minus 4, okay, divided by, the top I can take out an x, so x minus 2. On the bottom, trinomial, so numbers that multiply to be 8, that add up to be -6 are going to be -4 and -2. Okay, so before I do my keep, change, flip, I want to see what can x not be. So x cannot equal 4, 2, or 4, which I already have 4 included. Okay, so now I'm going to do my keep, change, flip. So I'm going to keep my first fraction, change to multiplication, flip the second fraction, and now I'm going to do my canceling whatever I can. So within this fraction, I see my x minus 2s are in the same fraction. We can do some cross simplifying, x minus 4s, x with x. So all I have left here is 2/3. Okay, now here's something else that I need to know. When I flipped this fraction, I got some new things in the denominator. I got this and this in the denominator. So I also cannot be 0. So after I flipped, I got x could not be 2 from this part. Well, I already have 2. But this one, x could not equal 0. So I do need to add that value in there. Okay, so check. So can't equal 0 and can't equal 0. Okay, so I need to check kind of at all 3 phases. Okay, All right, let's try another dividing one. So I'm going to factor first. So we've got x numbers that multiply to be 9 that add up to be 6 are 3 and 3. On the bottom, I can take out a 3. Divided by, factor out a 2. Difference of squares. Okay, right now, look at my denominators. What could x not be? So x cannot be a positive 3 or a negative 3 from this one. Okay, we're going to flip the second fraction. So now I have first fraction's the same. Change to multiplication. Okay, so now check again. So I already have x cannot be 3. This one, though, x could not be negative 2. So I need to add that one in there. Okay, let's do some canceling. So here I have x minus 3's that can cancel. And I think that's it. So now I'm going to multiply straight across. So I have x plus 3, x plus 3, x plus 3, 3 of them. So the short way to write that would be x plus 3 cubed over, on the bottom I have 3 and 2, which is 6, and then x plus 2. So this would be our simplified version, and these are the values of x that would make the expression undefined. Okay, last part of this video, you guys, we're going to do some solving. Okay, so here we want to check our solution. So what I'm going to do here is I'm going to get rid of the fraction. What I'm going to do is I'm going to factor first because I can simplify. So this factors into x plus 5x minus 5, difference of squares. Okay, so right away I notice x could not be 5, right? So I'm going to state that. All right, so these now could cancel. So I'm left with x plus 5 equals 14. Subtract 5. So this solution is good because it's not 5. If I were to get 5, then that's not a viable solution because that makes my expression undefined, my equation undefined. Okay, same with this one. Let's factor first. So I have, I guess I can state right now, what would make my denominator 0 is 2. So x could not be 2. Okay, so factor the top. I've got numbers that multiply to be negative 10 that add up to be 3. It would be 5 and negative 2. Okay, my x minus 2's can cancel. So I have x plus 5 equals 7. Subtract 5, I get x equals 2. But we just said x cannot equal 2. So this is really no solutions. 2 is what we call an extraneous solution. Okay? All right, that's it for this video, guys. Thanks for watching.